All right, it is 4:30 or no 1:30, and we are live. Ryan Jackson in the house.
Yo,
Yo, brother, good to see
how
you.
are you, my friend?
I am doing good. I'm doing good.
Good.
We were just chatting it up a little bit, and it sounds like you are heavy at work making a code change book, huh?
I am. Yeah, it's we're right at the 11th hour, so the 2023 code book will probably come out around September 15th is usually the norm, and I like to have my book out right around there as well. So this is the sixth time I've done a code change book, and did it four times for Holt, and 2020 and 2023 were for IEC. So it's nice. It's an exciting process. You get to know all of the changes that are coming up, but it's a stressful process as well. And I'm looking forward to be doing done.
Excellent, excellent. I'm just testing. I just want to see my audio. I know we got John McCamish is John.
Oh, John McCamish! No kidding.
Yeah, yeah, Nihad's out there. So John and guys and gals out there, how does my audio sound?
No kidding.
Hold on. I'm good. I'm good. All right. Yeah, I'm good. I just wanted to make sure because my levels weren't looking good. I sound like a doctor, Ryan. My levels aren't looking good.
Nice.
All right, so we got Nihad, we got John McCamish. All's good now. All right, and he says, hey, so, and David Engelhardt, what you're supposed to do is subscribe on the YouTube channel, and when you hit the bell, it notifies you when we go live, right, Ryan?
That's right.
Absolutely. So why don't we do this? I know people out there know you, but I don't know if Kendrick Webb knows you or I know John McCamish knows you. Why don't you do just tell us a little bit about yourself?
Sure. Well, this is the part that I hate the worst. I make a living teaching seminars and writing textbooks on the NEC. So for a person that makes their living speaking to people, talking about myself is always the part of the class that I hate the worst, the first 5 minutes. So my name's Ryan Jackson. I'm based out of Salt Lake City, Utah. And I work for myself just kind of as a code nerd, to be quite honest. I teach classes on electrical code, and I write books on electrical code, and I dabble in NFPA 70E as well. And I do consulting, expert witness work, things like that. I was an inspector for about 16 years or so. Before that, I was an electrician. I've been in the trade since I was 18. And that's kind of a little bit about me. I'm on Code Making Panel 17 for the NEC, which covers appliances, heating equipment, and then swimming pools and similar installations. And yeah, I'm just kind of a code dork. That's what I do, and that's what I love.
That's pretty good. So now let me ask you a question. Hate the worst. Is that a double negative?
Hate the worst? Could be. But actually, you probably misheard. I was saying that I hate German sausages.
Oh,
so, yeah.
Okay.
So, yeah, German sausages are the worst.
That's right. That's right.
I can't believe I pulled that back in. Nice.
You did.
I wouldn't possibly have misspoken. We know that's not going to happen.
That was beautiful. Willie Snyder, happy Friday. Okay. All right. So, Ryan, the conversation is I got a question. Actually, you recall, I believe you and I were talking about 215.15, the new requirement in the 2023 code that no.
Okay. That's
this
14.
was This was the secondary side of the transformer, and requiring the barriers on the secondary side of the transformer, and there it is. So there's an NEC requirement that says when you have or actually it's going to be a 2023, and I got to find the section number, but it talked about requiring barriers on the secondary for that panel board or whatever is being supplied on the secondary of that transformer to barrier off the line side lugs. And the problem was, and you pointed it out, as well as Palmer Hickman, and Palmer called me about it, and he's like, help me understand this. And Palmer sent me a note saying, so when are you coming out with panel boards that have every lug barriered inside that panel board? And
bus bar and everything else.
Exactly. And I, quite frankly, I was sitting there thinking, what's he talking about? And you know as well as I do, when you read some language, it's like you got to read it a couple times and you go, oh my God, yeah, now I see it, right?
Well, especially when I'm a big believer that you cannot edit your own writing. Somebody else has to, because when you know what you're trying to say, you'll convince yourself that you said it. And the fact of the matter is, you probably didn't. If you misspeak, you're not going to be the one to catch that. It's going to be somebody else. So
yeah,
15 is the right section.
Yeah. And so you know what? Sometimes what I've heard people do is they will read whatever it is they're writing backwards. Did you ever do that?
Well, I don't think I have the capacity for that now.
I don't think I have the capacity for it. Okay, so I'm going to put this language up real quick because this is what was one of my stimuluses for this discussion. And 215.15, close this other computer. This is what we ended up with on panel 10. Barriers have to be placed such that no uninsulated, ungrounded bus bar or terminal is exposed to inadvertent contact by persons or maintenance equipment while servicing load terminations in panel boards. So it only impacts panel board, switchboard, switchgear, or motor control centers. And you supply them by feeder taps or transformer secondary conductors in C when the disconnecting device to which the tap conductors are terminated is in the open position. So I was focusing, and what I think you and others pointed out was that it doesn't say anything in here about energized, that only barriering off what's energized when that main overcurrent device is turned off. Because we took that from in 230, if you remember I can't remember what section, but in Article 230, we have similar language, but the parent text included the energized part.
Okay, yeah, that's in 230.62C, I think.
Yeah, let's just double check your math.
I probably should.
230.62C. It sounds right, but I've learned that I can't trust my memory.
Oh, tell me about it. Especially when the code change, when the sections change every 3 years, you have to forget what you've learned and then relearn it. Yeah.
So if you look at 230.62, it says enclosed or guarded energized parts. So in the parent text of 230.62, it said energized parts, and then in C, it talked about the barriers. So when we moved that language over, we did not bring over energized. So I had a TIA, which I think there's only one dissenting vote on it so far, and I know it's been through the recirculation. So all I did was said barriers shall be placed such that no energized, uninsulated, ungrounded place. So we added energized, comma, right? I believe that's exactly where we put it. Now, when I was looking at this, I went down to here at the same time. This was when I was developing my TIA. Down here it says load terminations or motor control supplied by feeder taps in B or transformer secondary conductors in C. Okay? And then it says when the disconnecting device to which the tap conductors are terminated. So I said, well, wait a second. We said to which the tap conductors are terminated. What about the transformer secondary conductors? Okay. So I had created a language that I circulated to a few different people that said, to which the tap conductors or transformer secondary conductors are terminated. And so what I got back was, Tom, those conductors are tap conductors.
Yeah, and I agree with that statement.
Okay. So, but not all of them are. Okay.
Okay.
Not all
Fair enough.
transformer secondary conductors are tap conductors, because what you got to do is
Almost all of them are. Almost all of them are.
all of the common ones that we see, right? When aren't they? When would you say they're not a tap conductor?
Okay, well, a tap conductor, it's when people think of a tap conductor, usually they're thinking of a big wire and we splice a couple of smaller wires to it, and those smaller wires are tap conductors.
Right.
And indeed, they probably are. But when you look at 240.2, it's a beautiful definition. A tap conductor, and 240.2, of course, in the 2020 and previous editions, and Article 100 in 2023. But the definition of a tap conductor is a conductor that's not a service conductor. So we can't have a tap conductor service conductor. That doesn't exist. It's just a service conductor that's a conductor that's not a service conductor, that has upstream overcurrent protection that exceeds the normal rules in 240.4. That's all it is. So in 240.4, I think it's 240.4F, it talks about a pretty rare installation where you can use the primary's overcurrent device to protect the transformer secondary conductors. And there's some criteria that has to be met. The main part is that the secondary conductors have to be a single voltage, like 240 or 480. Not 120, 240, not 277, 480, but like a corner grounded delta, or an ungrounded delta, or a single phase, 2-wire secondary.
Right.
All of which are pretty unusual. So you can protect the secondary conductors with the primary overcurrent device. And in that case, it satisfies the requirements in 240.4, and therefore it cannot be a tap conductor by definition.
So what are they?
They're feeder.
Right.
They're feeder.
Okay.
And whether really the conductors leaving the transformer are always going to be a feeder, right? Because the conductors that leave a separate drive system or other power source and terminate to an overcurrent device are going to be a feeder.
Yeah.
And interestingly, transformer primary conductors are also feeder conductors.
That's right.
We a lot of times would tend to think of them as a branch circuit because they start at a breaker or fuse and end at equipment,
Right.
but they don't end at utilization equipment.
Right.
It's equipment. So transformer primaries are a feeder, transformer secondaries are a feeder. And almost every application of transformer secondary conductors are also tap conductors.
So
Do you agree with that?
okay, so let's okay. Now you're going right where I want to go, because here is my issue, and I
feel
don't.
like there's going to be a spinning saw blade at the end of this corridor that you're leading me down here. I'm curious to see what's going to happen.
Yeah, no, but it is. You're saying everything that I was saying, and now I want to look at the definition again that you read for a tap conductor. It says a conductor or other than service conductor that has overcurrent protection ahead of its point of supply. Ahead of where is ahead of its service supply? Where exactly is that? Is that at the beginning of the conductor? Could it be the main overcurrent protected device that's on the facility that's 3 or 4 levels up? Where is ahead?
Yeah, it's a term that I'm not in love with, to be honest. And I was looking at that this morning. But I think its source of supply is the circuit breaker or fuse where it originates, or potentially a literal power source, right? I mean, it's the generator wires or the transformer secondaries. So I think generally speaking, it's the overcurrent device where that circuit originates.
Okay, so on the secondary. Okay.
Yeah.
So now let's go back to okay. Where that circuit originates, where does the transformer secondary conductor originate?
At the windings.
At the windings. So if there's no overcurrent protective device there that's protecting it, right? In any case, even if the primary considers protecting it, that would mean that it doesn't meet the tap conductor definition, because there is no overcurrent protective device ahead of it. The only
All right.
you see what
Let me look one more time.
it
A
says.
conductor other than a service conductor
Yep.
that has overcurrent protection ahead of its point of supply that exceeds the value permitted for similar conductors that are protected as described elsewhere. Yeah, so I think ahead of the point of supply
Yeah.
would be the primary overcurrent device.
Okay, so it's not at the origination of the circuit then.
Well, I think that is the point of supply.
For the secondary overcurrent protective device, for the secondary conductor, conductor, you're saying that secondary conductor doesn't originate on the secondary windings. It originates at the primary overcurrent protective device.
No. I'm saying it does begin. It originates at the winding.
Okay, at the secondary.
So, yes.
Okay.
The secondary winding.
And so when we say that the overcurrent protective device is ahead of that, you're saying it is not at that not at the point of origination. It's before its point of origination.
Yes.
Okay. All right. And if that's so, and I've heard people read that definition two different ways. I agree with what you're saying. But I've heard people say that the point of that the tap conductor, and this is more than one person, and, so and this seems to be a point of contention. So I would agree with you, in my opinion, that it would meet that if the primary overcurrent protective device doesn't protect the secondary conductor, then it would be considered quote unquote a tap conductor.
Yeah.
Okay.
But you can make an argument, and a sound argument, because a tap conductor, like I said, normally we think of a big wire tying into a couple of smaller wires.
Right.
But a tap conductor can originate right at an overcurrent device. So if I have a 400 amp breaker and I want to run 3/0 out of it,
yeah,
as long as I meet the provisions in 240.21b, that's permitted. That is allowed. Yeah. But now, if you want to talk out both sides of your face and say, well, wait a minute, that's not the protection ahead of its point of supply. That is the point of supply.
That is the point of supply. That's right. So that's right.
You can't make a sound argument. Yeah. And I'm making both arguments here, and I hate to do that, because like we were saying earlier, I think we both know what it wants to say and what it's trying to say.
Yeah. And that's that's what makes, and that's what helps, I think, what makes better code is when you can recognize that there is a clarity issue there, because it does confuse some people. We understand what we're talking about, but when you take someone else who is looking at this, maybe doesn't do that many transformers, maybe they're a residential wireman and they do a lot of resi stuff, and then they come across a transformer and they read the language, and some people can be very, I don't want to say anal retentive. I'm saying some people read things very literally.
No, not at all. And I'll tell you, as an instructor, and I'm sure you've been there, there's two people in the room when you're teaching a class. There's two people that will completely knock you out as an instructor. One is when you say something and a guy raises his hand and he goes, well, according to section 6.8.2 of UL standard 489, and it's like, okay, this guy obviously, like, he lives and dies by this product standard. He probably invented the product. This dude knows what he's talking about.
Right.
The other guy that will completely turn out your lights is a first-year apprentice. A guy that just raises his hand and he says, that's not what it says.
Right.
Because he hasn't been conditioned he hasn't been taught wrong yet.
Yeah.
He hasn't had that opportunity. So the guy that doesn't know anything is beautiful. I remember in one of the Star Wars movies, Yoda says, beautiful is the mind of an apprentice. And it's so true, right? Yeah. Because they haven't destroyed their mind by bad instruction.
They haven't been corrupted. They haven't taken a Ryan Jackson class yet. Excellent. Okay, so we're clear on that one. Tapped off the conductor, the actual device is still ahead of the point of supply, which is the terminals. So John's saying technically that overcurrent protected device is still ahead of the point of supply, because the overcurrent device, it's the terminals, it's the load side terminals of the overcurrent protected device. So, and the overcurrent protection is still ahead of it. So that's what I'm saying. Fair enough. And I agree. I agree with everything that's been said so far. Now let's go back to this. So we had this discussion of when I first suggested this, I had a few people, a couple people, more than one, let's just say, that said that all conductors on the secondary of a transformer are tap conductors, and my first reaction is not true because of the definition of tap conductors, that if the primary device, co-overcurrent device, protects the secondary device, then it is not a tap conductor. But the challenge with a transformer, and as you and I both know, when you have this secondary piece of equipment, usually has a higher, I'll call it risk, likelihood and severity, because it has a higher severity, right?
Absolutely.
It's the same, whether it's a panel board that's on the secondary of a transformer, the likelihood is the same regardless of where that panel board's at. But the severity is higher only when I am selecting the primary overcurrent device with an inflated instantaneous pickup to ride through the inrush, right?
To clarify, when you're talking about the risk and severity, you're talking about an arc flash, right?
Yeah, the severity of an arc flash event, correct?
Right.
Yes. Yeah, because
Well, I totally agree.
Yeah.
The most incident energy you're going to find usually is, at the service equipment or transformer secondary.
Right. And right. So let me ask you a question. Am I picking the primary overcurrent when I pick the primary overcurrent protective device, does a transformer that has a primary overcurrent protective device that protects the secondary because it's a delta, right? That's one condition. Delta transformers, I'll just say delta. Let's say it's a delta.
Delta that's not a high leg.
That's not a high leg, correct. A delta. Does a delta transformer have inrush current like a delta Y ground transformer?
I thought so.
I agree with you.
I think I might be taken to school here. I sure thought so.
You're right. I agree with you 100% because a transformer is a transformer. It's a big iron core. You did good.
That's what I was thinking is like, well,
Yes.
yeah, stupid. Of course it does, but
Now, and the reason I say that is because when I pick that primary overcurrent protective device, like I have right here on this transformer, right? There's my transformer inrush. I'm going to have inrush current regardless of whether or not it is a delta Y ground, all that jazz. It's going to have inrush current.
Mm-hmm.
I am providing an intentional delay of the primary overcurrent protective device instantaneous, right? This one here has a short time delay, but I could put a circuit breaker that doesn't have a short time delay, and my clearing time for a fault on the secondary is going to be cleared by the primary's overload region, right? Which is going to produce a high incident energy.
A long duration.
Because
yields high incident energy.
Right. So hence why I went to this language and said we need to put or transformer secondary conductors in there. And because of the controversy, because of it seemed like a simple change to me. I did not put that in my TIA. I think that's going to be for a 2026 cycle because the hazard is exactly the same that we're trying to mitigate with that barrier. Because what you're doing with the barrier is you're reducing the likelihood of causing a fault in that secondary piece of equipment. And the severity is still high, whether that piece of equipment is connected to a delta Y ground, on all that jazz. It's still going to have the clearing time for a fault on the secondary is still going to be a long time.
Yeah, and I agree. And the concept of having the barriers at the service equipment, I absolutely love that change when that was put in 2017. I thought, here's a solution that we can provide for $2 that removes a real hazard. And on service conductors, it's especially important because I can shut off the main breaker and everything downstream of the breaker is off. Mm-hmm. But those service conductor terminals are on unless I call the utility and have them come out and shut off power. And look, we live in the real world. how often is that going to happen? Not that often.
Right.
So
Right.
we beat electricians over the head with OSHA and 70E, and we yell and say, work safely and turn it off. And then don't give them a realistic way to do it.
Right. Yeah.
That barrier gives you a realistic way of working in a de-energized condition, in an electrically safe work condition. Now, what you have here on your language is if it just says transformers that are supplied from tap conductors, I think that, number one, that's going to give you 99% of your transformers. It's going to give you those barriers, which is what you want.
Yeah.
On the other 1%, when we have a delta or single phase, 480 to 120 or something.
Right.
On those other applications, usually the transformer is only going to be supplying one piece of equipment, usually. And me as an electrician, if I have to work in that one piece of equipment, that downstream device, I could just open up the primary overcurrent device and remove the hazard.
If it's close by, right?
If it's close by. And remember, 450.14 says that the transformer has to be marked to indicate its location of the primary disconnect if it's not within sight.
Correct.
And 312, I think maybe it's 312.8 or so, we have to label the panel board to tell us where the source was. So we're making it easier for electricians to shut things off.
Right.
But the reality is sometimes people just refuse to do that. So I think this provides a lot of increased safety for the electrical workers, and it reduces the likelihood, like you said.
Yeah, it reduces the likelihood, and it's cost effective. I mean, it's not like you're breaking the bank to put a small rubber, I call them booties, but a small rubber barrier, right. So, but in any case, but this generated that discussion of, are those secondary conductors a tap conductor, or are they now here's my other issue. Here is my other issue which is on the same lines as this discussion. When you go to 240 and you can see my tap section has seen a lot of wear because I get a lot of questions about taps. Now, if you look at 240.21, 240.20, I got it backwards. Okay, 240.21 is the title of that section is location in circuit, right? Mm-hmm. So you have A, branch circuit conductors, and then you have B, feeder taps. They don't, if you look at B, feeder taps, if you look at C, it's titled, or I'm sorry, not C, D, that's service conductors. E is busway taps. Then you have motor circuit taps. Mm-hmm. You have, but transformers.
Yeah, batteries, I think.
Yeah, but it just says battery conductors. Mm-hmm. So, but it doesn't say battery taps. So is a battery conductor a tap?
Well, 240.21, before you get into A through H or whatever it is, F, 240.21, the parent language, the charging language, says overcurrent protection must be provided at the start of the circuit.
Correct.
It's easy for people to just skim over that and not contemplate what that means. It doesn't say you have to have an overcurrent device at the start of the circuit.
Correct.
It says you have to have overcurrent protection, which means protection against what? Ground faults and short circuits and overloads, all three. If you don't have protection against all three, you don't have overcurrent protection, right? So I could have, for a tap, I have a feeder tap. Let me make sure I'm 240.21b. Mm-hmm. I have an upstream overcurrent protection device. I have a breaker or fuse, but it's not providing overcurrent protection. Correct. It's providing ground fault and short circuit protection.
Right.
And that's why for a feeder tap, they have to terminate to an overcurrent device to provide overload protection.
Right.
And between those two, we have overcurrent protection. Right. And that's the whole reason 240.21 exists, is to allow me to not have all three types of protection at the start of the circuit. And for a transformer secondary conductor, they don't have that protection at the start of the circuit because they start at a transformer winding.
Right.
The primary device provides ground fault and short circuit protection. The device that the secondary conductors terminate to provides the overload protection.
Yeah.
Right.
Yeah.
So when we look at 240.21a through F or H or whatever it is, Most of those conductors are similar in that regard. And then we have something like batteries, which says, okay, well, the wires leaving a battery obviously do not have any ground fault or short circuit protection at their point of origination. Neither do service conductors, right? The utility conductors do not have overload protection upstream of them.
Right. So we treat those, and since to your point, the overload protection is provided on the tail end, on the load side of that conductor. We do special things for the length of that conductor, like service conductors. You got to protect it a certain way. You got to provide physical protection and things of that nature. You can't take it and route it in certain locations.
And not just because the overload protection is downstream, but the longer those transformer secondaries go, or the longer those feeder taps go, the longer those go, the greater their impedance is, right? And the greater the impedance means that when they have a short circuit, the lower the amount of fault current they're going to generate, and the less likely that upstream device is to trip. So if I make them too long and too small, you're still going to have overload protection, right, when they terminate downstream. But that upstream device might not provide ground fault and short circuit protection.
Right, because the short circuits might be in the long time region at that point, and now the fuse is actually the wire, right?
Yeah, exactly. That's exactly right.
Yeah. And so if you look at the transformer secondary conductor requirements in 240.21c, they tell you when it's provided by the primary overcurrent protected device. So we covered that, and then they say, okay, now if it's not protected by the primary overcurrent device, you can't. You have a various scenarios you can do this under. One, if it doesn't exceed 10 feet, right?
Yep.
So you have to limit it by 10 feet, and there are other requirements in there too. The ampacity of the secondary conductor is not less than the combined calculated loads. They give you all of these different things that you need to follow. And then if they give you special, provisions, if you're in an industrial application, they let you go a little bit further, 25 feet, right? And it's a supervised, those are the supervised industrials, right? And they still have conditions that you still have to meet. And then they say, okay, now if it's outside, so if your transformer's outside and the transformer secondary conductors are outside, they give you a whole nother set of rules, and they let you go 25. No, not outside. The unlimited length. Yeah. So now, and so now your conductors are outside. If they burn up, then or something happens, then they're outside.
They're outside. Exactly. Yeah. You don't burn down buildings from faults that occur outside.
Now,
and we have to allow an unlimited secondary conductor. We have to, because if we have I want to say medium voltage. I don't want to kick that can.
You saw my eyebrows go up.
Right. Yeah. Exactly.
Yeah.
So if we have a customer-owned substation, and we step it down, right, just for power bills and things, and then we step it down to 480 to feed our building, that outdoor transformer might be a significant distance away from the building.
Yeah.
Just like your utility transformer might be.
Yeah.
So we have to allow outdoor secondaries of unlimited length. That has to be permitted.
I agree.
There's no feasible way, in my opinion, that we can just limit outdoor secondary conductors.
Yep. And then you're accepting some level of risk associated with that. But there are provisions in there that say, look, if you look at that outside, because I like to read it, where the conductors are located outside the building, following the conductors are protected from physical damage, right? So you're reducing the likelihood of damaging them. The conductors terminate in a single circuit breaker or a single set of fuses that limits the load. The overcurrent device of the conductors is an integral part of the disconnecting means, or shall be located adjacent there too. And then it says the disconnecting means for the conductors is installed at a readily accessible location complying with one of the following: outside of a building or structure, inside the nearest point. So you can take those conductors inside if you're going to terminate it on that. Where installed in accordance with 230.6, nearest point of entrance of the conductor. So they give you some of those rules, but they're keeping the majority of those conductors outside.
Yeah, and basically, and I hate to compare them to service conductors because that can create confusion, but it is the same requirements.
Yes.
When you have service conductors entering a building, they have to what? They have to remain outdoors or terminate at the point of entrance.
Yep.
It's the exact same thing for transformer secondary conductors. But to be honest, it's the same thing for any type of circuit. If I go to part 2 of Article 225, buildings supplied by branch circuits or feeders, It already says if you supply a building with electricity, you have to have a disconnect at or on that building, and it has to be at the point of entrance.
Yep.
So most of the rules for transformer secondary conductors and feeder taps are actually pretty easy. They have to be protected from physical damage. Cool. Don't run THHN on the sidewalk. Fine. Easy enough.
Yep.
They have to serve the load. Every wire has to serve the load. That's never an option, right?
Yep.
So protect them from damage, serve the load. They have to be terminated at a breaker or fuse that provides overload protection, right?
Yep.
That limits the amount of current to the ampacity of the conductors. And then you get that really tough one that talks about the voltage ratio and 1/3 or 1/10 of the primary over current device.
Yeah.
But here's the thing. When I was inspecting, I did the math on every transformer I looked at, all of them, because I wanted to be really good at transformers and I wanted to be able to do it quickly. And, so I just did the math on every single one. I found that I think it's almost impossible to violate that part of the rule for a 10-foot secondary.
Really?
I think you would have to set your mind to it. You would have to intentionally design a code violation to do it. I mean, I'm going to throw down the gauntlet. Tom, come up with a design that violates that part of the rule for a 10-foot secondary. You'll be up all night and you won't be able to do it.
Doing the math, yeah.
You just, it's not going to happen. Now, for a 25-foot secondary, for a normal installation where we have a 480-volt primary and 208 secondary, if your transformer is supplying more than 3 different loads,
Yep.
then you could violate that. Because if you think about it, if I have one transformer feeding one panel, then those wires are going to be sized to carry 100% of what that transformer can do.
Right.
But if it's feeding 4 different panels, each of those set of conductors is going to be like 25% of what they normally would be sized.
Yes. And
once I start doing that, then you can actually violate that 1/3 times the primary voltage to the secondary voltage ratio. You can get into that, but it's still pretty hard to screw that up.
Yep. And now David Engelhardt had a good question, which is I think you touched on it. He says, can a secondary conductor from the typical 480, 208, 120Y 3-phase get tapped before the overcurrent protected device? And I'm assuming on the secondary, right? Third set of secondary conductors from a 5. So what he's saying is, can I come off of that transformer with, like, say, 3 transformer secondary conductors and land on 3 separate overcurrent protected devices?
Yes, you can do that. You can create as many sets of secondaries as you would like. What you cannot do is then tap one of those secondaries.
Right.
And that's in the parent language in 240.21, or it might be in the parent language of 240.21c, where it says a conductor supplied under the provisions of this section shall not provide another conductor unless it satisfies 240.4. It's either in 21. It's the last sentence of 240.21 before you get to A.
Oh, before you get to A. Yeah, there it is. Yeah, and I have it underlined. Shall not supply any other another conductor except through an overcurrent protected device meeting the requirements of 240.4.
Yeah, so you can't tap a tap conductor. You can't tap a secondary conductor. You can make as many sets of tap conductors as you want. You can have as many sets of secondary conductors as you would like.
That's right.
But you can't tap one of those secondary conductors and go to separate loads. So they'd have to go straight from the windings, right? And unless you were using the same size of wire, then it wouldn't really be a tap.
And there's nothing in the code that says you can't exceed the KVA rating of a transformer with the load.
Absolutely. Yeah. Transformers, the KVA rating do not have to be sized to satisfy any particular load. Though the conductors do, but the transformer KVA rating does not.
Yep. Okay. I had that question. All right. So this is this is so I get so many
talking code stuff. It's great.
It is. It's really good. So I need to just look at some of the comments here. So I got to scroll up. Hit the bell. We saw that. Sound is perfect. Happy. John McCamish, is that he likes your explanation of tapping? Oh no. Greetings, Tom. Robert from Omaha's out there. Part of the challenge is burned right. I don't know what that means. What about magnetizing current, inrush current? Outside service disconnects lockout for interior enclosed panel boards. PV systems. He's bringing up. So, okay, here's the other one, Ryan. Okay. A power source output conductor.
Okay. Now that's a new term in 2023. Is that correct?
It is. And here's it. Well, no, wait. Power source output conductor is actually, it's in the 2020 code, and they introduced it in 690, and I think it's 690 and 705, if I'm not mistaken.
Okay.
So here's my thought process. You have a service conductor, which isn't protected at the source, which, I don't know, many applications, they come off of the secondary of a transformer. You have the transformer
Scroll down to the definition here. Sorry.
No, that's fine.
Power
source output conductors, I believe you're going to find that. You might find it in 705.
Okay. Yeah. Sorry. I'm in the 2023. Okay. Conductors between power production equipment and the service or other premises wiring system or other premises wiring, right?
Yeah. And so, the conductors between power production equipment and the service or distribution equipment. So,
okay.
so I don't like that term. I really don't like it. And here's,
I don't think it's necessary. Number one.
I agree. But here's the thing. Here's what's, I'll tell you what's not defined. The conductor that comes off of a generator lug that goes to the first overcurrent protective device. It's not a service.
It's feeder.
It's a
feeder.
Is it a feeder?
It absolutely is.
Yeah, because the definition of feeder does not include language that says it has to be protected at the source because of 240 to right.
See, a lot of people when you think of feeder and when you first start learning it and really when you first start teaching it, you teach it as a wire that starts at a breaker or fuse, ends at a breaker or fuse.
That's right.
And for the most part it is. But it's also a conductor that starts at a power source that's not a utility.
Yes, that's exactly right.
Yeah. So that's why I say that power source output circuit or conductors. I don't think that definition is necessary because those were a feeder circuit, in my opinion.
Now here's and I know this is off topic, but I went down that road, and the problem that the PV guys have with the definition of feeder is it includes branch circuits or loads. And their comment was that there are no loads and branch inside of a PV distribution system.
Okay.
That was their beef with that language.
Well, and I'll be honest, I still, it almost takes a different upbringing in the electrical industry to think about PV systems really easily. Because for me, I grew up not doing PV systems. I grew up, wiring commercial buildings and small industrial. So for me, there's loads and there's a source and it's all linear and it works out easy. It's hard to remember that a PV system isn't a load, it's a source. So what are the conductors between there? So I guess I can understand the hard.
Yeah, and that's why, because I was like, I just hated that term, but I still hate the term. But I understand why they went down that road. Now here's a question: isn't it true there's no NEC prohibition on branch circuits in the same conduit as transformer secondary conductors on line side of breaker? Prohibited at services and okay for secondary of customer owned medium low voltage transformers. I would agree with that, right? I don't think there's no prohibition. You can put the only prohibition is service conductors and non-service conductors in the same raceway. Right. And then the other provisions, when you put any conductor in the same raceway, you got to think about the voltage ratings of the insulation and all that jazz, right?
Certainly. Yeah. Right. And on that, and that's in section 300.3c as in Charlie. And then there's an informational note that a lot of people don't read right after that sentence in 300.3c. And it says, go to Article 725 if we're talking about remote control and signaling.
That's right.
And I just want to emphasize that because look, you can have a remote control signaling circuit on 600 volt wire. It doesn't change the fact it's still remote control signaling, and it cannot be in that same conduit or communication circuit. So there's more to it than just the voltage rating. If the conductors are for lighting and power, then the voltage rating needs to be equal to or greater than the maximum voltage, and away you go.
Yeah.
But when it comes limited energy circuits or communication circuits, it's the function, not the voltage rating, that tells you whether or not you can be inside that same raceway.
That is
People screw that up an awful lot, I've found.
That is a very good point. Yeah, that's 300.3c. Conductors of different systems, AC and DC circuits rated 1,000 volts or less, shall be permitted to occupy the same equipment wire, enclosure, cable, or raceway. All conductors shall have an insulation rating equal to at least the maximum circuit voltage applied to any conductor within the enclosure, cable, raceway. Secondary wiring of electric discharge lamps, if insulated for the secondary voltage, shall be permitted to occupy the same luminaire, sign, or lighting. And that's an important part right there. And then you have the two informational notes, C725.136A for Class 2 and Class 3, and then also C690.31B for PV source and output circuits.
Right. Yep, absolutely.
Yeah.
So yeah, and there's a change. The language that prohibits service conductors and non-service conductors in the same raceway is found in 230.6, and there was a change that's going to happen in the 2023 that's going to increase that, to say, okay, not only can they not be in the same raceway, they also can't be in the same handhold enclosure. Like if I'm doing an underground splice, or the same in the same cable. But you can still put service conductors and non-service conductors in the same enclosure. And where people have heartburn with this, and the code has to say that, because on a service disconnect, you have to have service conductors and non-service conductors. By definition, you have to have them in the same enclosure. But where people have a real heartburn is once you start putting in transfer equipment and things like that, a lot of times you'll have service conductors that go all the way through a different enclosure, like a transfer switch. And that's permitted. That is permitted. That is not a violation, because the transfer switch, the enclosure, the cabinet probably, is not a raceway. So you can have service conductors in enclosures for things that are not service conductors. And I think that gets misconstrued an awful lot.
That's a good point. Never thought about that. That's a very good point. Very good point.
Yeah, I had somebody call me up just a few days ago. They were having trouble with an inspector in California that was going to make them basically redo their entire service because of that issue. And I ended up, showing a picture in the NEC handbook and one of my books and Holt's books that all show, yeah, you can do that. It's unusual, but it's not prohibited. And it might not even be a great idea, but it's not prohibited.
Yeah, I gotcha. All right. So the other item that I wanted to chat, I don't know if I mentioned this. I went. I think I was. Did I go live? I didn't go live this morning. I went live yesterday because I knew this morning was going to be a tight morning for me. But my favorite product. I got to tell you a story about this one. I was with a gentleman who was in charge of the safety for plants across globally, right? And I asked him, I said, what do you lose sleep over the most in your facilities from a safety perspective? And he said, the first panel board on the secondary of every transformer in my facility. He says the incident energy is high, and his electrical workers, they just shut the main off, just like we were talking about. They don't establish that electrically safe work condition where you have no exposed energized parts in there. So, and he says he worries about that. So I was with another gentleman from Eaton, one of my services division, and we were talking and we were brainstorming. I said, why don't you just put a disconnect in front of the transformer, or in front of the panel board, and just put like an AC disconnect, a heavy duty disconnect, to turn it on and off so that you know. And he's like, it's expensive. I have to put another raceway in. I got to find a spot for it, and on and on and on. And then I said, boy, wouldn't it be awesome if we could integrate the breaker with the transformer? Just put that secondary breaker right inside the transformer on the secondary, and then you can just go to the transformer and you could kill it there on the secondary. You could also kill it if you're doing on the primary. Not only do you have to find the transformer, which may or may not be, hopefully it's 10 feet away or whatnot, right? Depends on the application, but
could be in a different building.
It could be, and then the feeder for that transformer could be in a different building too, right? Yeah. So to try to kill power to a transformer can be a challenge for for a service guy and you know as well as I do, if it takes an effort like that, it's just, hey, just shut the main off. What's my exposure? It's just these main lugs. Just be careful. Don't touch it. So I said, what if we put it in there? And my services guy says, if we can't get the product line to do it, he says, our services division, we can list products. We can make this and then get it listed as an assembly. I'm like, oh, this is really great. So I go back to my office and I send an email down to the plant. And I said, guys, I got an idea. And I explained everything that I just explained to you. And you know what they did? They sent me a link to this. A breaker integrated transformer, which we had out for 4 freaking years.
Well, you guys already had it.
We already had it. And then so I'm sitting there and I'm like thinking I got the greatest idea since apple pie. And I'm thinking, man, I've got like the product line is going to carry me around on their shoulders and all this good stuff,
Employee of the month, man. Employee of the month.
Employee of the month club, I'll have my own special parking spot right out in front, All these visions went through my head. And then the product line was like, duh, we've had it out for 4 years. Tom, where you been? So I love this product because they did integrate that. They have the primary and the secondary. I personally, I can understand the need for the primary. So if you want to kill everything, it's right there. But that secondary breaker, which provides the reduced incident energy downstream, which if I go to this, I did an example. Where is it? Maybe it's not. Yeah, I think it's right. Is it? There it is. So if like on this here, this is a one. I think it's 112.5 kVA transformer. Okay, I have 12.7 calories per centimeter squared on the secondary, which is pretty significant, right?
Oh yeah,
it's pretty significant. But
a lot of people's kit ends at 12.
Yeah. Oh, yeah, that's right.
That's a cutoff. So
yeah, that's a cutoff. Yeah, I never thought about that. You're right. Now, if I break this overcurrent protected device off and take it out of that panel board, and I could put it in my transformer, right? Just build it into, or I could put it, because my argument to this gentleman was, why don't you just put a disconnect right in front of that piece of equipment? We do that in our Beaver plant where we make circuit breakers. We put a circuit breaker in a box, and we put the arc reduction maintenance switch on it, supplying power to like all of our control panels and stuff like that. And the reason they did the arc reduction maintenance switch on it was because if it's a piece of equipment like machinery, the likelihood of doing justified energized work is high because you're troubleshooting, Yep. So the philosophy of the plant manager was to put these breaker in a box with an arc reduction maintenance switch so that when justified energized work was done, the incident energy was low. But it also provides the ability to turn it off right there. Okay. So and I talked to him about this, and his complaint was really, it was not just expense, but it was space. You need to find the room to do that on the wall. But then, and that's when we said, well, what if we just incorporated this into the transformer? Your 12.7 calories moves up, and the incident energy down at that panel where you might be doing justified energized work is only 0.17, which is a huge decrease in incident energy, and that's conservatively high, probably.
But when you say that the 12.7 moves up, you're saying right at the transformer secondary terminals, it might be 12.7.
Yes.
But anywhere downstream, it's lower. It's perhaps less than 1.
Yes, exactly. And it depends on the length of the conductors because you're reducing the fault currents and things like that. But it was one of those things where I backed into it. What was kind of cool was when you have an idea, totally innocent, you're sitting there and you think you have a really good idea, right? And you don't know that this stuff exists. And then you find out that someone else had the same good idea, right? So that's sort of like a validity to your like, hey, you know what? I might be slow. I might be at least 4 or 5 years late.
Right.
But you
did get there on your own. It's
I
like
did
when
get there.
that's happened a lot with patents, where two
Yeah.
people apply for the same patent that have never talked to each other, and they apply for it, days apart, because
Yeah.
it's just like it's the zeitgeist where it's like, okay, it's time for the steam engine, and I guess Fulton won the foot race and got the patent, but
Yeah.
the other guy was there. He wouldn't have stopped to tie his shoe. We wouldn't know who Fulton was.
Absolutely right.
The other thing, and I love that integrated transformer, and I always start my kind of train of thought always starts with the code instead of with safety, just because that's what I do mainly.
And they're related.
But there's some code benefits to that breaker integrated transformer as well.
What's that?
And that is, in 240.21, you're not allowed to take advantage of the next size up protection device, right? So if we just don't open the code book and we say, hey Tom, what size breaker do you use to protect 500 kcmil? You're probably going to say 400 amp.
Yeah.
And in most applications, that's true. But when you have a 112.5 kVA transformer that's 480 to 208, that's going to give you 400 amps on secondary. And I couldn't tell you how many times I had to write it up as an inspector because people go brain dead. They say, 400 amp breaker, 500 kcmil. No, not for a transformer secondary. You have to run 600 kcmil. So depending on the length of your secondaries, that could pay for itself. I don't know what the price of copper is right now. I know it's, out of this world. So I can't help but wonder how many times that integrated transformer breaker would end up paying for itself.
I never thought about
between 500 and 600 kcmil.
I never thought.
If you're doing an outdoor unlimited length, that will pay for itself. That period. That thing will pay for itself.
But here's the other thing. I can go an unlimited length with a BIT with that breaker integrated because I have an overcurrent protected device.
It's not a secondary conductor.
That's right.
It's just a feeder. Yeah.
Right. My secondary conductor is a short piece that goes from the breaker, and it's probably bus bar that goes to that. Right. And now my that is a standard feeder that I can go any length from that transformer.
Absolutely. Yep. Absolutely.
Yeah.
And it doesn't have to be in a raceway per se, so it could be in a cable.
That's right.
And that's something that I have a little bit of contention with, is that secondary conductors and feeder taps have to be in a raceway, so you can't use a cable. They could be in an auxiliary gutter, but not a wireway. They could be in flexible metal conduit, but not MC cable. But that's another little beef that I have, and hopefully I'll get it fixed for the 2026 NEC.
Well,
a little oddity there.
Yeah, that's an interesting point. But I never thought about the size of that conductor. I wonder, that's just a 112. But what about the other transformers? I could look at other transformers and try to. I have to. So here's the other part. People ask me, what do I do? Right? It's these types of things that I try to help the product line create, like notes and informational pieces to help customers understand these little nuances that can save them. They save them money, but also I focus on increasing safety. I think about the likelihood and severity for the electrical workers, but there's also a benefit from a cost perspective that could pay for whatever added. I don't know that it's that, because you're moving the cost from the main overcurrent device in a panel board to putting that same overcurrent device. So I've never done the pricing because I don't really get involved in prices, but
yeah,
you could probably look and say, what does a panel board with a main overcurrent protected device cost versus a main lug only panel? And then the standard breaker versus a breaker with an integrated secondary breaker.
And the difference in size of the secondary conductors and the labor to bend it and everything else.
Oh man, I never thought about that.
Yeah. Yeah. Well, you engineers never think about the labor to bend the wires and everything.
I've been conduit once a long time ago when I worked with my cousin, and I wasn't too bad at it, but I wasn't too good at it either.
But on a serious note, though, there's a phrase that you use a lot when you're doing videos, and that is solutions. You say, okay, we have a solution for this, and we have a solution for that, and really that is kind of what it's all about. The Eaton product line offers solutions for different scenarios. I mean, that's what you're doing. So
Yeah,
the integrated breaker transformer is a solution at the end of the day.
that's true. And I had to get that in before we got off because that's what I do. I want everybody. I love when people ask me what's my favorite product. It used to be GFCI's, but now it's the BIT. Breaker integrated transformers. David Engelhardt says service conductors passing through a non-service intended enclosure does not seem to comply with NEC 312.8A3.
Well, 210.12.8A3 tells me I have to have a sticker on the panel that warns me that I have feed-through conductors, and I have to identify the closest disconnect. So the sticker that you would have to put on there would simply have to say the closest disconnect is up there on the pole. Have fun. Unless they've made a change that I'm not aware of.
I don't think so. So he says service conductors passing through a non-service intended.
Yeah. So you've got a cabinet, a disconnecting means, so a cutout box or a cabinet, and it has service conductors passing through it. So you have what we might call conductors feeding through that enclosure, feed through conductors, and 312.8, excuse me, easy for me to say, 312.8 is the section that tells you how to size enclosures when they have splices, taps, or feed-throughs. So you can run feed-through conductors through that enclosure. You just have to tell people that they exist. So you're going to put a sticker on there that says warning feed-through conductors, and the closest disconnect for them is up on the pole.
That's right. Yeah.
It's unfortunate, but that's where the closest disconnect is.
Yeah, and then John says so. They are okay. John's on a roll. Oh my gosh, he's got. Look at this. Look. Okay, so John says secondary conductors are feeder conductors that have installation requirements similar to tap conductors. Since they do not have overcurrent protection, I would agree. Well, they have overload protection on the secondary. They don't have short circuit protection, right? So they are either feeder tap conductors simultaneously, or they are feeder conductors that are secondary conductors.
Okay, so there's a subtlety here. They are feeders, and they are tap conductors. And I think for the most part, I think we came to a consensus on that.
Yeah.
Are they feeder tap conductors? I don't know. I don't know what that is because that's not a defined term. We don't use the term feeder tap conductors. 240.21b says feeder taps. It doesn't say feeder tap conductors. It just says feeder taps. If I'm not mistaken, I
believe you are right. It just says feeder taps, but it says conductors shall be permitted to be tapped without overcurrent protection at the tap. So where John I think is going is where I was sitting there. So here was my thought. I said, if you call a transformer secondary conductor a tap, okay,
a tap conductor.
A tap conductor, right? So is that, and it's a feeder, right?
Yeah.
So it's a feeder tap. So Ryan, I would say you have to follow the rules in 240.21b because it's a feeder tap. It's a feeder. It's a tap. It's a feeder tap.
No, it's a feeder and it's a tap conductor.
But then, what's a feeder tap?
Tap conductor is a noun, right? It's not just tap. It's tap conductor. So you have a feeder and you have a tap conductor, right? Both of those are defined terms. We just happen to call that thing a transformer secondary conductor.
So what you're saying is a feeder tap is not a defined term.
It's not a thing. It's just the title. It's just the title of 240.21b. That's all it is.
Okay, so you have feeder tap, and then you have transformer secondary conductors. So where I think John was going, feeders, and he's saying feeders and tap conductors, feeder and tap, not feeder taps. No, it's not a feeder tap. Okay, right. I should send John the link so he can dial into this. But so here was my thought process. When I was looking at, I go back and forth. I look at 240.21 and I think, why? How do you make it clearer, right?
Yeah.
When you say transformer secondary conductors, that would apply regardless of whether or not it's a tap conductor or not, because it's a transformer secondary conductor.
Correct.
Right. So that would mean that even if, and I got to look at where's the language? It says, where's transformer secondary conductors? Oh, it's on my others. Yeah. It says a set of conductors feeding a single load, or each set of conductors feeding separate loads, shall be permitted to be connected to a transformer secondary without overcurrent protection at the secondary. So that tells you that C is when there's no overcurrent. Well, it says no overcurrent protection at the secondary, period. Right. Not that there's no overcurrent protection, right?
Right. So because C1 is that unusual delta
right.
single phase, right? So that's right. One method of protection.
So in my mind,
and that does not create a tap conductor.
Correct. So in my mind, if a transformer secondary conductor that's not protected by the primary overcurrent device is a tap conductor, then you call it a transformer secondary tap conductor. Just like we call it a motor tap conductor. And sure. then even you could take 240.21, create a section, call it tap conductors, just tap conductors. And then under tap conductors, you can have a feeder tap. You can have a transformer secondary tap conductor. You can have a motor tap conductor. And then in 240.21, you could create another section that's not a tap conductor, but it's a transformer secondary conductor. That's not a tap conductor, and say, look, you can, for a transformer secondary conductor that's not a tap conductor, then you can have the overcurrent protected device on the primary side of that transformer.
Yeah, and I think to a smaller extent, that's how they used to do it, because transformer secondary conductors is a relatively new thing in Article 240. I say relatively new, I mean 25, 30 years. If you go back to like the 80s in Article 240, there was no transformer secondary. They were just called feeder taps back in the day. Right. And then they kind of made that distinction to say, okay, yeah, they're feeders. Yeah, they're tap conductors, but they really are unique. They are their own thing. And it's a complex enough issue, keeping conductor insulation from melting is a lot trickier than we think.
Oh, absolutely.
When it's just, when it's a 20 amp breaker for your bathroom and it trips under ground fault, short circuit, and overload it, it's pretty simple. When you get into motors and you get into transformers and you get into taps, it's a little more complex. So we need as much, and then we need as much clarity as we can have. And to your argument, maybe it's time for a little bit more clarity. Yeah, and I think that's a valid argument.
Yeah, and so as I read, and the only reason I say that is I don't, I thought I knew this, right? And when I get questions, when you get questions and people will say, wait a second, a transformer secondary conductor is not a tap conductor. Well, why do you say that? Well, it's not included in the tap conductor section. It's got its own section called transformer secondary conductors. And you go, well, that's true. That's true. And then you got to go back to the definition, and you got to back your way into supporting your thought process. But the other person on the other side has some valid arguments and so it just seems to me that whenever you have those areas in the code that create this type of dialogue, and I think that there's room for improvement. Now, I've heard some people, I'll never forget, and I won't mention names, but I made a public input. And I won't say what panel it was, but I wanted to add some clarity.
Come on.
Okay. Yeah. So I'll tell you, it was panel 9. I wanted to add in the transformer, and it's related to this discussion, in 450. Because I get this question all the time. People forget. They'll take the secondary of a transformer, put a main lug only panel in it.
Oh yeah.
And I say you can't do that. It's very rare. So then they'll say, well, wait a second, I blah blah blah, and they do the math. I'm like, well, hold on. In the panel board, when you have a panel board, in panel boards, 408. Yes, 408 tells you that, look, you have for a secondary, it has to be on the secondary of the transformer, and it's really hard to not have it. So, and I go back and forth. So what I did was in 450 for transformers, in the table, I wanted to add a note for the secondary protection to remind people to go back to 408 that if it's a panel board, etc. So I just wanted to bring that link in for that secondary, and it was they told me
I think I know who it was.
Yeah,
I have a pretty good idea.
I'm still in the room, right? And he knows me, and he goes, this gentleman doesn't understand that the code is not for the uneducated and the untrained, and it was. I mean, I just was plastered. I mean, I
definitely know who it was.
Oh my gosh, I was plastered, and I'm like, well, hey, you know me, and I'm sitting right here, and I'm like, oh my god. But
that's awesome.
But I think there are those who will say, when you try to add clarity, that not to add that clarity because it's not for the untrained person. They go back to Article 90, right? Yep. And they'll say, look, it says right here, it's not for the unqualified and the untrained person. But I think we have a responsibility to add clarity, because clarity can increase safety because more people will enforce it correctly.
That's exactly right. Yeah, and when it comes to transformers, there are multiple articles that really have to work in harmony.
Yeah.
The transformer winding and nothing else is protected by 450.3.
Yes.
Right? That protects the transformer itself, the equipment. When it comes to protecting the wiring on the primary, we go to Article 215 because it's just a feeder circuit.
Yep.
When it comes to protecting the secondaries, we go to 240.21 because it has some unusual requirements. And then the load goes back to 408.36 usually because we're supplying a panel board.
Yep.
But it's really easy to try to melt those all together. When you go to 450.3, the table, and it says, okay, how do you want to protect the transformer? You want to just use the primary protection? You can do that. If you make your breaker small enough that primary breaker will never allow the transformer to melt, then cool.
Cool. Yeah, and you'll never energize it because it'll be so small, the inner's current will trip it.
Right. So if you go above 125%, well then, okay, we can do that if you make the secondary overcurrent protection device the right size, and we can do it that way, right? And now you made the secondary overcurrent device bigger, probably gonna have to make the secondary conductors bigger, and make sure that the panel board is still protected at its rating. If it's only rated 225, but you put in a 250 or whatever, well then now we might have some issues there. So I agree, clarity does yield safety ultimately, and it is important. Some things are complex enough where you don't get to go to an 8-hour class and call yourself a journeyman electrician. So there is, to that gentleman's point, we can't train people with the code and nothing else. So we do have to write it for people that are trained. But we do need to make it as clear as possible. I completely agree with that.
And the big section a lot of engineers that I talk to miss is 408.36 B. Supplied through where a panel board is supplied through a transformer, the overcurrent protection required by 408.36 shall be located on the secondary side of the transformer, and there is the exception, which is for that delta and those and you would not believe the number of designs that I've been sent, and I look and they go, and their argument is, well, I'm not exceeding the 6 disconnect rule. I have 6 or less. And I said, well, yeah, but you're violating this one.
Right. I used to write up transformer installations all the time as an inspector because there are so many rules. And we haven't even talked about the grounding and bonding of the system and the equipment. That's a whole different topic. So when it comes to transformers, it's easy to screw them up, and fortunately, when it comes to actual safety, it's also extraordinarily hard to make a transformer melt down. In reality, you can screw up a transformer and probably not kill anybody. So
here's another question. Last one.
Oh, all right. Love it.
75 degrees C or 90 degrees C?
For
transformers.
75. When it comes to conductor sizing, 75. Yeah. You know, you can use the 90-degree rating for separately installed connectors, and let's remember, we are talking about feeders, right? The conductors, the primary or the secondary, are feeders, and they have to comply with 215.2 because they are feeders.
Yeah.
And 215.2, there was some clarification made in the 2020, maybe 2017, that says you can use the 90-degree column for separately installed connectors, but those connectors have to be created outside of the original enclosure. So here's where you can really use the 90-degree column. Here's where you can really use it.
Yeah.
You got a switchboard outside, right? And you come out of the switchboard or switch gear, whatever, switchboard, into a gutter, into a gutter or a wireway. So you can take your 500 kc mil right out of your 400 amp breaker, and then you go to that gutter. And then you splice onto there with some smaller conductors. And you go underground into the building and you hit another gutter. And then you splice on to bigger wires and feed the panel board, right? That's where you could use 110.14c and 210 or 215.2 exception.
But even in that enclosure, it has to be listed for 90 C.
Yes. Oh, the terminations have to be rated 90 degrees.
Yeah,
absolutely.
And so here's what I learned was, and what a lot of people think is that the 75 C is only related to the overcurrent protective devices.
Oh no, not
right. Wrong. It's not.
Yeah, it's all terminations, all of them.
It's about the temperature in the enclosure, right?
Yeah, and the temperature of the equipment. So like just a twist-on wire connector, right? I've trained myself to not say wire nut because that's ideal, So twist-on wire connectors, push-in wire connectors, split bolts, what have you. They're all going to have a temperature rating as well. Yeah. So the wire may not melt, but if the wire connector does, well, then what did we gain here?
That's right.
So, but it's easier to get a higher temperature. Like I say, a twist-on wire connector, those are rated 105 C. Yeah. Now, there is no 105 degree C ampacity for the conductor, but you could go, what you could do? You could go out of a panel with, let's say we're using THHN, right? Not Romex, not NM cable. I could come out of a panel for a range. I got my 2-pole 50 amp breaker. I could come out of there with 6 gauge, leave the panel, go to a box, use twist-on wire connectors, and I could downsize it to 8 gauge and utilize the 90 degree ampacity to a separate enclosure.
You're right.
Put some twist-on wire connectors back on, and then increase it back to 6.
Yeah.
Because I'm worried about the terminations. There's 4 terminations in that circuit: the breaker, the wire connector, the receptacle, right? And you treat the middle of the wire differently than you treat the ends of the wire. We have to deal with the ampacity of the wire and the temperature rating of the connectors. They're 2 completely different.
Absolutely. Things. And the requirement that you mentioned about, or the permission in 215 for feeders, right, that we put in there, we didn't need it.
No,
you don't need that. It's exactly right. It's all in 110. So I could have done everything that we put those requirements in for. We could have done that without any change in the code whatsoever, because the code doesn't prohibit it, and it's following the NEC. And I made that argument at the table whenever we were looking at it. I'm like, I don't care, put it in there, but you don't need it.
It didn't really do anything. The one thing that it did is it did clarify that you have to leave the enclosure before making that connection. And really, and I think that makes sense, because you have to have at least a long enough wire to act as a heat sink.
Sure.
You can't just put a little 1 inch of wire and then make it smaller and think that that's going to change.
Exactly.
Anything.
Now, David Engelhardt said, what about, remember we were talking about the, this is like a never ending thing. Remember we were talking about the secondary, the jobs I keep seeing, a panel board with 6 disconnecting means and a feeder going to that panel board, right? Not into landing on a circuit breaker, but going to a main lug only panel, okay? He says, what about note 2 of table 450.3b? And note 2 of 450.3b says, where secondary overcurrent protection is required, the secondary overcurrent devices shall be permitted to consist of not more than 6 circuit breakers or 6 sets of fuses. Well, David, my example that I gave was a main lug only panel with 6 disconnects in it. That's not permitted because there is no overcurrent protective device that you're landing on. you have to land on an overcurrent protective device based upon 608.30, whatever. You have to land on an overcurrent device, and then you can only have 6 of those on the secondary of a transformer. You can't put them all in one panel board.
Well, and let's remember that says where secondary protection is required, and secondary protection of the transformer winding is only required if I'm running transformers in parallel through like a main tie main, or if I exceed the 125%, normal primary only method. So number one, it doesn't come up that often. But number two, if I did, let's say I have a transformer and my inrush was such, or maybe I just screwed up, or I put too big of a primary overcurrent device in, it exceeds 125%. Well, I can go up to 250% if I incorporate secondary protection as well. So what if I did that? I screwed up, put in too big of a primary overcurrent device, and out of my transformer, I'm feeding 6 different panel boards. They're grouped,
right?
And they each have a main overcurrent device.
Right.
That could be compliant. That would satisfy 408. And that's where you would read that note to the table and say, okay, you actually are providing secondary protection through the use of 6 separate devices.
Right.
And their accumulated value, very rare that you would see that, but it does recognize.
And that's the second sentence that David was talking about, where multiple overcurrent devices are utilized, the total of all the device ratings shall not exceed the allowed value of a single overcurrent protected device.
Yeah, exactly. Because the cumulative value of those is providing the winding protection for the transformer.
Right.
Yeah, not the conductors, not the panels. That's just taking care of the transformer winding.
Right. But if you have a delta Y ground transformer, you better land that transformer secondary conductor on an overcurrent device.
100%.
100%. And you can have 6 of them. You can have 6 of them, fine. But
sure.
Yeah. You can't go more than 6 though, right? Would you agree?
Well, you could. So let's say I'm protecting my winding by using the primary only method.
Oh, yes.
So I could have 10 sets of secondaries out of that if I wanted to.
Oh, that's right.
Because I don't need secondary protection unless I've got 2 transformers in parallel and they're going main time main.
Amen. There we go.
But here's where you would run into that problem in 240.21c6, I think, that says the transformer secondary conductor amp capacity must not be less than 1/3 of the primary overcurrent device times the primary to secondary voltage ratio.
Yeah.
You start getting 10 sets of parallels, you're going to have a problem satisfying that requirement.
Yeah, that makes sense. All right. Okay, so 408.36, 408.30.
Love it.
Yeah.
Deep diving Article 450 with my man Tom. What a way to spend that Friday afternoon.
We had a blast, huh?
I certainly did.
I enjoyed it because what's funny is when we started this, I was working on so many other things before we started, and my intentions were last night. I wanted to pull some slides together. This morning, I thought, because I had all kinds of crap going on last night. This morning, I couldn't because I had all kinds of phone calls. I had meetings. And then I'm like, crap, this is going to be a tough call. I mean, I know there's a couple of things I want to talk about, but man, we hit a lot of cool stuff.
Yeah, well, I just looked down at the clock, and it's like, that's spun pretty fast.
I know.
For me, it did anyway.
I know.
The audience might be up there with their car keys, hitting their wrists over this, but I enjoyed it.
Well, we lost John McCamish not too long ago, so he says he had to go. David, it would seem secondary conductors can terminate into a main lug only panel per note 2, and that's not true, David. You can't terminate into a main lug only panel because of note 2. That would be an error.
Remember the 450.3 and 240.21 have nothing to do with each other.
That's right.
Nothing whatsoever.
Yep. Secondaries of Transformer sounds like a Michael Bay sequel. Michael Bay.
The director of Transformers.
Oh, okay. There's the keep reading. You guys did a terrific job. Felix Sandoval. So we were international today. John Doss. Nice. Nihad, and Nihad's not in Egypt right now, so he's back up in Canada, but that's still international.
Okay. Nice.
Still international.
Nice. Outstanding.
It's standing out.
Outstanding. Oh, I like that. Wow. Yeah. No, you have to be careful with the word you say. You say that that's incredible, and it's like, you're saying I have no credibility? What's the matter with you?
It's true. That's true. Yeah, it is so freaking true. All right, Ryan Jackson, thank you for your time today.
My pleasure. Anytime. Always happy to stop by and have a code chat.
So why don't you do a plug? Where, I mean, what can people get from Ryan Jackson these days, and where do we go?
More of this, right? More code fun. Swing over to my YouTube page if you haven't already. Just search for Ryan Jackson Electrical.
Excellent.
And make sure you like and subscribe and ring the bell, and like me on Facebook, hate me on Twitter, be indifferent to me on Instagram. You know, do all of those things. But more than anything, reach out and say hello and stop by the YouTube channel.
That's awesome. So much success to you and your tubing and your tubing friends. And you have a book coming out again, right?
I do have a book coming out. Should be available in early October, I'm hoping. So that'll be through IEC. You don't have to be a member, but go to iectraining.com and you can get all my textbooks. I've got a 3-volume set that covers pretty much the entire NEC, and it's 3 volumes. In fact, I might as well grab it.
Here we go. Look at this.
Oh, home. So there's you want to learn about the NEC? There's 3 books that cover it from Article 90 up to Article 830. I don't cover Article 840 because Article 840 is a complete waste of time.
Article 840 is a complete...
Article 840 it's meaningless. But anyway, so yeah, there you go. Thousands of fun photographs and pictures and things. So yeah, go to iectraining.com and you can get the books there. I've got code changes books, explanatory material, slides. If you're an instructor, you can buy my code change. I think my 2020 code change slide deck, I think, is like 1,500 slides. So enough to keep you occupied for days. You know?
Do you do training out in the field? I mean, if somebody wanted you to come to their facility?
All the time. That's pretty much how I spend most of my time is training, either for associations, you know, for IEC and IAI in different places, or at facilities. I do a lot of on-site facilities.
And all of the images in your training materials are all of Eaton equipment only, right?
Of course, whenever possible. Yeah, of course. I mean, why would I use brand X?
Wait. Hold on. I said all of them are definitely Eaton, and you said, of course, whenever possible. Well, I mean, that's like saying I always do this sometimes.
Do you really want to continue this little thread here? Whenever possible, I use Eaton products, of course.
You're awesome. All right, brother. I really appreciate you, Janet. Ryan, thank you.
I've had a great time, man. Thanks for having me, and it's good talking to you, all of you guys out there on YouTube and Facebook and everywhere else. So be safe, please.
Awesome. Be safe and stay healthy.
Indeed.
All right, guys. And thank you, Ryan, again. And thanks everybody out there. We had Robert from Omaha, Jeff Bauer, Brandon Reed, Nihad El Sharif, John Doss, Felix Sandoval, David Engelhardt. Love you, brother. Brian Rock.
The Rock Lobster.
The Rock, the McCamish. I'm just looking at the names. Oh, man. There's so many good people. We have a
panel 2 here.
Yeah, we did. We had a lot of panel 2 people. Willie Snyder.
Brian, Nihad, John.
Yeah, that's right. We could write code. Gonna love it. All right, Ryan. Thank you, sir. Take care. Awesome, stay safe, and please stay healthy, brother.
All right, man. You too, Tom. Take care.
Right, take care. How do I had an ending screen here somewhere. I just deleted all this stuff. I'm just going to hit stop.
Works for me.
It works for me. And stop. Where's my stop streaming? I got to find my stop. There it is.
I'm just going to sit here and make it uncomfortable.
Yeah. Awkward. I'm stopping streaming. 3, 2,